Module 6, Lesson 12, Describing the Center of a Distribution Using the Median. So far we have looked pretty much at using the mean or the average to describe the center of a data set, and now we're going to be looking at the median. And the median is super easy, so kind of fun. So we're going to find the median of a given data set. So how do we summarize a data distribution? What provides us with a good description of the data? Well, so far when we've summarized the data distribution, we've looked at the mean, and we have looked at the variability. How spread out is the data? In this lesson, we are going to look at the median as a measure of center. So these two give us measure of center. The mean gives us a measure of center. The median gives us a measure of center. Variability talks about how spread out are we from the center. So we're going to try and understand how we can answer that question. So here's our first example. We've got a chain restaurant, McDonald's, Burger King, In-N-Out, somebody, that advertises a typical number of French fries in a large bag is 82. So they say a typical amount of French fries you would find in our bag is 82 French fries. This dot plot shows the number of French fries in a sample of 20 large bags from restaurant A. So they took 20 bags from this restaurant, they counted how many French fries there were in each bag, and they put this on the dot plot. So it looks like we've got one bag with 66, and one with 67, and one with 72, and one with 73. So this is our 20 bags from restaurant A. So what could the restaurant mean when they say the typical number of French fries in a large bag is 82? So they have said that 82, right here, this is the typical number of French fries in a bag. What did they do to come up with 82? Stop and think about that for a second. Well, it could be that what they did is they found the mean. They added up all of these numbers and they divided by 20, and they came up with 82. So we find 82 on the dot plot. And you'll remember you use this little balance symbol to kind of show where the center is. So what do we notice about the data values that are above 82 and are below 82? So taking a look here, what do we see? And taking a look here, what do we see? What observations can you make? Well, let's see, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on this side. And I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on this side. So I've got 10 above it and 10 below it. Well, that looks pretty centered to me. Are there any other observations that you make? Well, let's see. So this is 82 here in the center, and we go all the way down to a 66 over here. So we've got a difference of 16. And we've got 82 here in the middle, and we go all the way up to 93. So we've got about 19 over there. So we're kind of in the middle there too. Well, interestingly, we've already made one of the observations. We have the same number of data values on either side of 82. We have 10 to the left and we have 10 to the right. So 82 is in between the two halves. So the restaurant used a summary measure called the median. So the most important observation from that last slide is that we had 10 bags to the left and 10 bags to the right. The restaurant used a summary measure called the median to describe the typical number of French fries. Sometimes it's useful to know what point separates a data distribution into two equal parts. One part represents the upper half of the data values. That's this is the upper half. And one part represents the lower half. And there's our lower half. The point that separates the upper half and the lower half is called the median. That's our 82. And we'll talk about how we picked 82 instead of 81 or 83. We'll talk about that. When the data are arranged in order from smallest to largest, the same number of values will be above the median point as below. So, important concept here. We put our data points in order from least to greatest: 66, 67, 72, 73. We've got 77, 77. We've got 79, 80, 80, 80. So we need to list them in order from least to greatest, and we find the middle. And we're going to practice all of that in a few minutes. So you just bought a large bag of French fries from the restaurant. Do you think you have exactly 82 French fries? Why or why not? So looking at the data here, do you think your bag has 82 French fries? And what's your reasoning? Well, it looks to me like there's a lot of variability here. So none of the bags had exactly 82 French fries, so mine's probably not going to have 82 French fries either. The bags that were in the sample had from 66 to 93 French fries. A lot of variability. None of them had 82. I'm probably not going to have 82. Exercise 2. How many bags were in the sample? Remember, each dot represents one data point or one bag. So we had 10 over here. We had 10 over here for a total of 20 bags. There we go. All right. So looking at the data, which of the following statements would seem to be true for the data that we were given? And explain your reasoning. Half the bags had more than 82. Well, that's a true statement. We just talked about that. Half the bags had fewer than 82 in them. We talked about that too. More than half the bags had more than 82 fries in them. And that's not true. We had 10 on one side, 10 on the other side. More than half the bags had fewer than 82 fries in them. No, that's not true either. If you got a random bag of fries, you could get as many as 93. Well, let's see. The very top number here was 93, so we know that that is a possibility that you could get a bag with 93 fries in it. So A and B are true because there are 10 bags above 82 and 10 below 82. Statement E is true because that happened once, so it could probably happen again. So this is A, this is B, and this is E. So looking at a second example, this is grades on a science test. How many data values are represented on the dot plot above? Remember, every dot represents one data value, so we count up the dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. We've got 28 data values on the dot plot. So how many data values should be located above the median and how many would be below the median? Remember, we want half above and we want half below. So if there are 28, what is half of 28? 14. We want 14 above the median, and we want 14 below the median. So we could count here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this is below. And this would be 14 above. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the median is somewhere in here, somewhere between 80 and 85. Now, of course, the question is, how do I decide which number between 80 and 85? And we'll talk about that in a minute. So for this data set, 14 values are 80 or smaller, so that's this direction, and 14 or 85 or larger. So the median needs to be between 80 and 85. When the median falls between two values, in this case 80 and 85, we use the average of the two middle values. So we're going to take 80 and 85 and we're going to find the mean. We're going to find the average, and that would be the median. So to find the average, I'll take 80 plus 85 and get 165, and then I'll take the 165 and I'll divide it by 2. And I'm going to come up with 82 and a half. And of course you can use a calculator for that. I did it out longhand, but go ahead, use a calculator. So the median of this data set is going to be 82 and a half, exactly halfway between 80 and 85. So what does this information tell us about the data? I've got the median here at 82 and a half. I've got half my values here. I've got half my values here. What does that mean? The median tells us that half of the students in the class scored below 82 and a half on the science test. Remember, the median tells us the middle. So I've got half of the students here, and I've got half of the students here. Whenever we talk about a median, we need to realize that means we've got our data split into two halves. So what percentage of students scored higher than the median? Well, if this is half, what percentage is that? And if this is half, what percentage is that? Half is equal to the decimal 5/10, which is equal to 50 hundredths, which is equal to 50%. 50% of the students scored higher than the median, and 50% of the students scored lower than the median. Suppose the teacher made a mistake and the student who scored 65, so this student right here, actually scored a 71. Is that going to change the median? Why or why not? The median's not going to change. I've still got 14 scores over here. I've still got 14 scores over here. I'm still finding the middle of 80 and 85, so nothing changes there. Suppose the student who scored a 65 actually scored an 89. So the 65 here now all of a sudden moves over here and becomes an 89. Is that going to change the median? Remember, our middle was here. Now I have 13 over here and I have 15 over here. The median is going to change. I've got 13 on the left side, I've got 15 on the right, so 82 and a half is no longer the median. So a grocery store usually has 3 checkout lines open on Saturday afternoons. One Saturday afternoon, the store manager decided to count how many customers were waiting to check out at 10 different times. So if I were the store manager, I'd be asking myself, do I have enough checkout lines open? Well, what I'm going to do is I'm going to check at 10 random times and see how many people are in line so I can decide if I have enough checkout lines open. So she collected her data, 10 different data points, and she found out the median was 8 customers. Now, why might the median be an important number for the store manager to consider? What is important about this median? Well, that means half the time there were more than 8 customers waiting to check out. If the median is 8, that means half of the time I have more than 8 people in line. Who likes standing in line at the cash register? Now, that also means that half the time we had less than 8 people in line. So if I were the manager, I'd look and say, if I only had 3 checkout lines open, I'm probably going to be opening some more because there's a lot of people waiting in line at least half the time. So brainstorm, what is another example of when the median of a data set might be useful? Come up with your own example and then compare with a little bit of my thinking. Well, when the data are about how much time students spend doing homework, it'd be interesting to know the amount of time that more than half the students spend on homework. So if I'm asking for the median amount of time, what is the middle amount of time? That helps me know what's happening more than that. And it also gives me a good idea of who's spending less than that. So if I'm looking at the number of points earned in a competition, it'd be interesting to know where are the top half of the competitors and where's the bottom half. If you scored at least this many points, you're in the top half of the competition. If you scored less than that number of points, you're in the bottom half of the competition. So, the owner of the chain, the restaurant chain, decided to check the number of French fries at another restaurant in the chain. So here are the data for restaurant B. So we've got their data set here. Now the first question is how many bags of fries were counted? Each of these numbers represents a bag of fries. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. We counted 19 bags of fries. Oop, got stuck there for a second. Now, Sally claims the median is 75 because she sees that 75 is the middle number in the data set. She thinks that half of the bags had fewer than 75 because there are 9 that come before 75 and 9 that come after 75. So she counted and said there are all of these numbers of French fries here, and she said that we were going to have 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 before this, and 1, 2, 3, 4, 5, 6, 7, 8, 9 after. So 75 is the middle of the data set. Do you think that she might change her mind if she put this on a dot plot? Stop and think about that for a second. She is probably going to change her mind when she put this on a dot plot because these numbers are not in order right now. Remember, clear back at the beginning of the lesson we said the numbers need to be in order from least to greatest. So we can't find the median unless the data are organized from least to greatest. Putting the number of fries in each bag on a dot plot is going to put the data in order, and we're probably going to get a different halfway point because the data above are not in order from least to greatest. These are just all jumbled up. Now if we look at the data, we can ask ourselves, what is the median? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Ooh, looks very different than the 75 that Sally thought. Jack said the median was 83. Jake said the median was 83. What would you say? Now I'm going to show you a strategy that I use for finding the median. I take one off the left, one off the right. One off the left, one off the right. Left, right, left, right, left, right, left, right, left, right, left, right, left, right. Jake, I don't think that the median is 83. What I think Jake saw is that there were more bags that had 83 than any other number. I think Jake was looking at a different measure of center there. 83 is the most common number of fries in the bags, but it's not the middle. The middle is at 82. Now Betsy argued that the median was halfway between 60 and 85 or 72 and a half. Do you think she's right? So Betty comes along and says, I'm going to take 80 and I'm going to subtract 60 and get 25, and then I'm going to divide that in half and get 12 and a half. And so I can take 60, add 12 and a half, and I'm going to get a middle of 72 and a half. What do you think of Betsy's reasoning? Although it's kind of interesting, you look at 72 and a half and here it is. Does that look like the middle at all? Not really. So I'm afraid, Betsy, that that's not very good thinking there. The median's not calculated from the distance or the difference of the largest and smallest amounts in the data set. It's not the same as finding a point that separates the ordered data into two parts with the same number of values in each part. Remember, for median, we're looking for middle. The middle of all of these numbers. Chris thought the median was 82. Do you agree? Why or why not? Well, we've already done this on a couple of other slides, but if we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 1, 2, 3, 4, 5, 6, 7, 8, 9, I've got 9 on each side, 82 is the median. Chris is correct, because if you order the numbers from least to greatest, the middle number is going to be the 10th number, with at most 9 bags that have more than 82, so I've got 9 over here, 9 that have less than 82. 82 is our median. So calculate the mean and compare it to the median. What do you observe about the two values? If the mean and median are both measures of center, why do you think one of them is smaller than the other? So to find the average, we'd add all of the numbers together and we'd divide. And we would find that the mean is 78.6. The median we found is 82. Now the reason for this happening, why did the mean drop down, is we had this one bag down here that was way less than everything else. So that dragged the mean down. It brought it way down. So something important to pay attention to when you talk about measures of center is, do you have any numbers that are way out there that kind of mess things up? The mean can be very affected when you have really low numbers or really high numbers off by themselves in a data set. I don't think 85 is kind of off by itself. It's pretty close to 83. But this 60, that's a long ways away from a 70. So we have to watch out for numbers that are way out there, especially when we talk about the mean. The median doesn't get affected by those super low numbers or the super high numbers. All right, a third restaurant, Restaurant C, tallied the number of fries for a sample of bags of French fries and found the results to the right. How many bags of fries did they count? Well, every tally mark represents one bag. So there would be 26 bags of fries. Now, if I'm thinking halves here, half of 26 is 13 and 13. So my median needs to have 13 values on each side. So what is the median number of fries for the sample of bags from this restaurant? And describe how I found my answer. Well, I could go and write out all the numbers, or what I could do is cross out tally marks. So I got one on this side, 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 one on this side. So what I'm doing is I'm working from the outer sides, the outer ends, toward the middle. And I have to be careful and keep good track so that I don't mess things up. And I think I did just mess things up, because if there were 26 values, I should have 13 and 13. I got talking and wasn't paying attention. So let's see. 1, 2, 3, 4, 5, 6, 7, 8. Oh, I didn't cross out the slash right there. Boy, that was silly of me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So to get down to there is 13, and I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so I am exactly halfway in between the 79 and the 80, because I have 13 79 and below. I have 13, 80 and above. So I take the 79 and the 80 and I find the average. And of course you could use a calculator. 7 times 2 is 14. 9 times 2, 18. So 79 and a half. So we have a median of 79 and a half. So we took the half of 26, which is 13, and I found 13 tallies, which was here, found 13 tallies, which was here, and then I found the halfway point between 79 and 80. Robier wanted to look more closely at the data for bags of fries that contained a smaller number of fries and bags that contained a larger number of fries. He decided to divide the data into two parts. He first found the median of the whole data set and then divided the data set into the bottom half, the values in the order listed that are below the median, and the top half. So we need the 13 bottom values, which is these. And we found the median of that. So this was the first 13, and we found the median. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Did the same thing with the top half. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So now our data set is split into 4 parts. I've got a 78. I've got a 79 and a half, and then I've got an 84. We've divided our data into 4 sections. So out of all of these restaurants, which one seems most likely to really have 82 fries in the typical bag? And so you'd want to go back and look at the different charts that we've looked at and ask yourself which one seems to be closest to the 82. So the data sets for restaurants A and B both have a median of 82. Restaurant B seems to have the most bags that are close to 82. So these two both have an 82, but the restaurant B seems to have less variability. Its numbers are closer to 82. The data for restaurant C has a median of 79 and a half. The data values aren't very spread out, and most of them are close to 82. So really you've got a few different possible answers depending upon how you look at it. So probably no right or wrong answer there. The question is, what was your thinking that led you there? All right, lesson summary. The median is the middle value in a data set that has been ordered from smallest to largest. Keep emphasizing this. You have to put them in order from smallest to largest if you're going to find the median. The median is going to separate the data into 2 parts. We will have the same number of data values below the median and above the median. To find the median, first we have to order the data. Put it in order from least to greatest. If there are an even number of data values, if I've got 4 of them, 1, 2, 3, 4, I have to average the 2 middle ones. If I have an odd number of data values, 1, 2, 3, 4, 5, I just need the middle. 2 over here, 2 over here, here's the median. So, hopefully you are feeling a little bit confident that you can put the numbers in order from least to greatest and that you can find the middle number that is known as the median. And that concludes Module 6, Lesson 12.